AES. So what is AES? That's nothing but Advanced Encryption Standard. In AES, I'm going to have 3 key length, that is 128 bit, 192 bit and 256 bits. In this step, each byte is substituted by another byte. Hello to all, a warm welcome to my new session on traditional symmetric key cipher. I'm Revati from the Department of Computer Science, Vidhyaashram, First Grade College, Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the things what I have covered in my last session of this unit. So dear student, in my last session, I started with data encryption standard. So dear student, it is very important from the examination point of view. You can able to expect this question or another topic, that is AES, either AES or DS. You're going to get one question under this topic. So then I explained general structure of DES. Along with that, I explained initial and final permutation and how to perform round function and how to generate key. So dear student, this is only for 7 or 8 marks. And if you get the question for 7 or 8 marks, in that situation you want to define what is DAS, then write the general structure of DES. Along with that, write what is initial and final permutation and what are the steps comes under initial and final permutation. Along with that, how to perform round function and key generation, so that you can able to get full marks. Now, in my today's session, I'm going to deal with advanced encryption standard. That is nothing but AES. And the features of AES and how this AES is going to work, the structure of AES, along with that, how to perform encryption, as well as the different steps comes under encryption. We are going to study in my today's session. So at the beginning, I'm going to deal with AES. So what is AES? That's nothing but Advanced Encryption Standard. If I consider key 128, it's always multiple of 8. So here I'm going to get 8. After that 16, 24, 32, then 40, 48, 56, 64, 72, 80, 88, 96, 104, 112, 120 and 128. So here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 11, 12, 13, 14, 15, 16. So it is mainly uses 16 bytes. Okay, so here it's mainly based on bytes, and if I go with 128 bits, then it is 16 bytes. So here AES algorithm is considered secure because it is the most commonly used cryptography system in order to provide security. So it is more secure because the length of the key is large and it is very difficult to detect the key size. So here this is the most commonly used cryptographic system. Now here see, this is the feature of AES. That means if I consider AES, what is the input size? That is 128-bit input. And I can able to make use of 3 different keys, that is 128 or 192 or 256-bit keys. And when I apply encryption algorithm, I'm going to get 128-bit cipher, 128-bit cipher text. So here, symmetric key, symmetric block cipher, it uses 128-bit data. Along with that, I can able to use 128-bit or 192-bit or 256-bit keys. So it is stronger as well as faster. Now let me to discuss how this AES is going to work. So here the AES algorithm is mainly based on this substitution and permutation. So here this AES algorithm is mainly going to work based on the confusion or substitution cipher as well as permutation, and it is responsible for performing all the computations on byte rather than bits. So here I'm mainly going to focus on bytes rather than bits. So here AES treats 128 bits of plain text as 16 bytes. So here I'm going to consider 128-bit plain text as 16 bytes. So these 16 bytes are arranged in the form of columns. So 4 cross 4 matrix. So all these 16 bytes are arranged 4 columns and 4 rows. That is nothing but matrix representation, and it is 4 cross 4. And the number of rounds depends on the key size. See here, it is depends on the key size. So the number of rounds depends on the key size. If I consider DES, the number of round 16 is fixed. But if I go with AES, the number of rounds depends on the key. For example, if I'm having 128 bits, then I'm having 10 rounds. Then 196, 12 rounds. And if I'm having 256, then it is 14 rounds. So this is the way I can able to select the round based on the key. I'm going to have different rounds. So the number of rounds in AES is variable and depends on the length of the key. That means whatever the number of rounds I'm going to have in my AES is mainly based on the key length. And here AES uses 10 rounds for 128-bit keys and 12 rounds for 192-bit keys and 14 rounds for 256-bit key. So each of these round uses different 128-bit round key, which is calculated from the original AES key. So here for each key length, I'm going to have different rounds. Now this is the structure of AES. See here, what is the input size? It is 128-bit plain text, and I'm going to use 128 key. That is, the size of the key is 128 bits. For that reason, I'm going to have 10 round function. So, I'm going to have 10 round function. And this input is given to the pre-round transformation, and the output of this pre-round transformation is input to the round 1. And after performing round 1, what is the output I'm going to get? That is the input to the round 2, and it's going to continue. And it's going to continue. And if I consider key expansion, for example, if I'm having 10 rounds, then I can able to have 10 keys. So for round 1, key 1, for round 2, key 2, for round 3, key 3, and it's going to vary for round 10, key 10. And if I consider the key size for 128, I'm going to have 10 rounds, and 192, 12 rounds, and 256, it is 14 rounds. Now, let me to consider how this encryption algorithm is going to work. Now, all the 128 bits are represented in the form of 16 bytes. So, it is represented in the form of 4 rows and 4 columns. That is nothing but matrix multiplication. So 4 cross 4, it is 16. So dear student, I repeat here, all the 16-bit plain text are treated as 16 bytes, and these 16 bytes are represented in the form of 4 rows and 4 columns. That is nothing but the matrix representation. See here, AES considers each block as a 16 byte, that is 4 byte into 4 byte, 128. That is 4 into 8 plus 4 into 8. That is what? 28. So here 4 byte plus 4 byte, it is 16 byte. If I multiply 4 byte into 4 byte, it is 128 bits. Now, it is represented in the form of column major matrix. So, here my block starts from B1, B2, B3 up to B15, and each round comprises of 4 steps. That means each round includes 4 steps. What are the 4 steps? That is round key, subbyte, shift row, mix column, as well as this is the round 1. Okay, it's going to include 4 phases: round key, subbytes, shift rows, and mix column. And see here, the input is, that is nothing but 128 bits. Okay, so I'm going to have the plain text, and what is the size of the plain text? It is 128 bits, and I'm going to 128 bit key to this round function. And how many round function I'm going to have here? Total 10 round function. Based on the key size, I'm going to have the round function. So I'm going to have total 10 rounds. Now see what is substitution of the byte. So that is nothing but sub byte. So how the substitution of the byte is going to happen? So this step implements this substitution. That means for individual byte, I'm going to perform substitution. So I'm going to substitute the bytes. In this step, each byte is substituted by another byte. So, in this step, each byte is substituted with some other byte. It performing using lookup table as called S box. So, what is this S box? It's nothing but the substitution box, and it is responsible for substituting the bytes. And the result of this step is 16 byte, that is once again 4 cross 4 matrix. Once again, I'm going to have 4 cross 4 matrix. Now, I'm going to have shift row. That means I want to shift the row. And how I'm going to shift the row? This step is just it sounds. That means I'm going to shift the row. And while shifting row, I want to follow the certain rules. So each row is shifted a particular number of times. Okay. And first row is not shifted. First, dear student, please make a note here. During shift row, I'm not going to shift the first row. So what I will do, I'm going to write this row as it is. So I'm going to write this row as it is. Now, if I consider second row, then I'm going to shift this row, that is shifted once to the left. So here, if I consider this one, okay, I'm going to shift this row one step left. So here it is, I'm going to shift towards left. Okay, now if I consider second row, okay, if I consider second row, I'm going to shift that row once to the left. See here, I'm having A10. So if I shift this one, it is going to come here. And if I shift this one, that is A11, A12, A13. Fine. Now, if I consider third row, I'm going to shift to left twice. See here, I'm going to shift this row twice. I'll consider 2, 3, 1, 2. So here, okay, fine. If I consider 2, 2, 1, 2, here, I'm going to get 2, 2. And if I consider 2, 1, I'm going to get here. And if I consider 2, 0, 1 and 2 here, I'm going to get 2, 0. And if I consider fourth row, it's going to shift thrice. It's going to shift thrice to the left. So here, if I consider fourth row, okay, and I'm going to shift thrice. So 1, 2, 3. So I'm going to get A33. Okay, now if I consider A32, 1, 2 and 3. So A3, 2. And if I consider A31, 1, 2, 3. So here I want to get A31. And if I shift A30, 1, 2, 3. So the second position I want to get A30. Now the left circular shift is performed. That means in shift row we are going to perform left shift. Now I'm going to have the mixing the column. That means I'm going to mix the column. And how I'm going to mix the column? By using matrix multiplication. So this step is basically a matrix multiplication. That means in mixing the column, I'm going to perform matrix multiplication, and each column is multiplied with this specific matrix, and thus the position of each byte in the column is changed as a result. So dear student, you just want to remember that in the mixing the column, we are going to perform matrix multiplication in order to change the column. So here I am going to perform the matrix multiplication. So here it is matrix multiplication, that is called mixed column. Moving further, I am going to have add round key. So this is the final step, and here the message. What is message? That is nothing but the plain text is XORed with the respective round key. So here I'm going to have the plain text and I'm going to have the key. Now I'm going to perform XOR operation in order to get my round key. Okay, so I'm going to have the plain text and I'm going to have the key. Now I'm going to perform XOR operation in order to get my, that is round key, in order to get my round key. So dear student, this is all about AES, and from the examination point of view, the AES as well as the DES is very important topic. You can able to expect DES or AES. Any one question is sure question, either AES or DES. Now I'm going to have the difference between AES and DES. So I'm going to have AES and I'm going to have DES with the definition. First, I'm going to define the difference with respect to definition. So, AES, that's nothing but Advanced Encryption Standard. And what about DES? That is Data Encryption Standard. And if I consider the key length in AES, 3 key length, that is 128, 192 and 256. But here, what is the key length? It is 56 bits. And if I consider AES based on the key, I'm going to have 3 rounds. Suppose if I select 128-bit key, then round is 10. And if I select 192-bit key, then the round is 12. And if I select 256-bit key, then the round is 14. And if I go with DES, what is the round I'm having? It is 16 and it is fixed. And if I go with network under AES, then AES structure is based on the substitution permutation network. That means here I'm going to use substitution cipher as well as permutation. And if I go with DES, then here we are going to use Fiestal structure. And if I consider security, AES provides more security than DES. If I consider DES, DES is weak. So DES is weak and AES provides more security. And if I consider rounds under AES, I'm going to have byte substitution, shift row, mixed column and key addition. And if I go with DES, I'm going to have XOR operation with round key, substitution and permutation, as well as I'm going to have the expansion. And if I consider the size of the plain text here under AES, it is 128 bits, and if I consider DES, it is 64 bits. And if I consider derived from, that means if I consider AES, it is derived from square cipher, and if I consider DES, it is derived from Lucifer cipher. If I consider next parameter that is designed by, here AES was designed by Vincent and here DES was designed by IBM. And if I consider the next parameter known attack, that is the possible attack, if I go with AES, then there is no known attack. And if I go with DES, then the possible attacks are brute force attack, linear crypt analysis and differential crypt analysis. These are the attack we can able to expect on DES. So dear students, these are the some difference between AES as well as DES. And this is the very important topic from the examination point of view. Dear student, let's see the difference between AES and DES. So here I'm going to define the difference between AES and DES in terms of keys. So at the beginning, I'm going to consider the definition here. So here, what is AES? AES stands for Advanced Encryption Standard, and what about DES? That is Data Encryption Standard. And if I consider length of the key, in AES, I'm going to have 3 key length, that is 128 bit, 192 bit and 256 bits. And if I consider DES key length, it is 56 bits. So here AES 128 bits, 192 bits, 256 bits. Under DES 56 bits. And if I consider round function, under AES, round function is going to vary according to the key length. If I select 128 bits key length, then I can able to have only 10 rounds. And if I consider 192 bits, then I can able to have only 12 rounds. And if I consider 256 bits, then I can able to have only 14 rounds. Now, if I consider DES, it's fixed. So here I can able to have only 16 rounds. And if I consider the network in terms of AES, then it is mainly based on the substitutional cipher as well as permutation. And if I consider DES, it's mainly based on the Fiestel structure. And if I consider AES with respect to security, here AES provides more security and DES provides less security because the key length is very less in DES. Now, if I consider rounds under AES, I'm going to have byte substitution, shift row, mix column and key addition. And if I consider DES, I'm going to have XOR operation, round key, substitution and permutation. And if I consider the size in terms of AES, it is 128. That means the plain text size here is 128 bits. And if I consider DES, the plain text size is 64 bits. And if I consider AES, it is derived from square cipher. And if I consider DES, it is derived from Lucifer cipher. And if I consider AES, it was designed by Vincent, whereas DES was designed by IBM. And if I consider AES, there is no known attack. And if I consider DES, the most common attacks are brute force attack, linear cryptanalysis and differential cryptanalysis. So dear student, from the examination point of view, this is also very important topic. So dear student, in my today's session, I started with what is AES. That's nothing but Advanced Encryption Standard. And from the examination point of view, AES as well as DES is very important topic, because here you're going to get only theory questions. Now, in my next session, I'm going to deal with encipherment using modern symmetric key cipher. So, encipherment using modern symmetric key cipher. So, this is all about today's session. Let's meet in the next session with some more information about modern ciphers. Until then, keep watching and keep learning. Thank you.